It's time to export the knowledge. In this video, we're going to be talking about uh, looking at the graph and identifying what quadratic equation this is. So there's two main methods that you can use to identify graphs like this. Here we have a graph and there's no scale, but we do have the turning point here, which is 2 comma minus 3, and we also have a point on the line 3 comma minus 2, and that's all the information that we have. So we're going to have to somehow come up with an equation that goes through both of those points and has this as the turning point. So let's do it. So this is what we have. We know that this is a point on the graph, and we know that's the turning point. Okay, so because we have the turning point, it would make sense to put it into turning point form. So we'll start with y equals, and then x, and something squared, and then we're going to have some sort of constant. Our k value is going to be minus 3. We can read that straight from the turning point. And our h value, our horizontal shift, is just going to be the opposite of whatever the x value is. So in this case, it's going to be minus 2. So there's an equation, but does it satisfy this? So what we need to do now is we need to sub in these values and see if the result is true. If it is not true, we're going to have to put some sort of gradient here and solve for it. So let's sub it in. So minus 2 is going to equal 3 minus 2 squared minus 3. So 3 minus 2, that's just going to be 1. 1 squared is 1, so we can get rid of the squared. So 1 minus 3 equals minus 2. So minus 2 equals minus 2? Yes, of course. We were lucky that we didn't have to work out some sort of gradient. In some cases, you would have to. So here's another graph that we are asked to identify the equation for. In this case, we have the y-intercept, which is 0, 6, and we have the two x-intercepts, which is 3, 0 and 4, 0. So with these points, we can use the other method to try and find what this is. Okay, so since we know the x-intercepts, it would make sense to put into the factorized form. So we'll start with y equals x something and x something else. So we can just take the opposite of the x values, minus 3, minus 4, and then we should be done. So now we just need to check. So because we have this identified point here, the y-intercept, we need to make sure that it actually goes through that point. The easiest way to do that is that because this is the y-intercept, we can just times the two constants together and we'll see what happens. So minus 3 times minus 4, that gives us positive 12. We shouldn't be getting positive 12. According to the graph that we saw, we should be getting positive 6. So the easiest way to fix that is to work out what gradient you need. So A in front of here, sub in x equals 0 and y equals 6. So 6 is equal to A lots of minus 3 lots of minus 4. So then you'll get 6 equals 12a, and then you can solve for a by dividing by 12, so a equals 1 half. So now we can say that our final answer is y equals 1 half of x minus 3, x minus 4. So for this graph, we know the two x-intercepts, and we don't have the y-intercepts, but we do have a point that it goes through. So with this information, we can find out what the equation is. Okay, so this is the information that we have, then we should put it into factorized form since we know what the two x-intercepts are. So x, and then we'll get the opposite, so it will be plus 2, and then the opposite, which would be minus 3. And now we can say that this is equal to y. So there's one. So the problem with this equation is that we saw that this was a curving downwards. At the moment it curves upwards. So we need to fix that somehow. Now, you could just put a minus here, but we have a point here that we have to go through. We might as well check that point against an unknown gradient a. So we'll put in 12 equals a lots of, and then we sub minus 1 in, minus 1 plus 2 lots of minus 1 minus 3. This will become a lots of 1 lots of minus 4. This will become minus 4a equals 12. We divide by minus 4, we get a is equal to minus 3. And there's the key step to make sure that this is indeed what we are looking for. So that's all the time that I have for this video. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.